Okay, well, good morning, 8th grade. I hope it's going well. We are now on 11.4, which is the very famous Pythagorean theorem. Pythagorean theorem. Spell this. Theorem. And we are on page 465. So I'd turn there if you want to follow along. 465. So I hope you all are doing well. We are in the last 2 weeks, so hang in there. It's coming. So this is the old famous a squared plus b squared equals c squared. Now this is where if you look at your book, right, we have this amazing picture. It looks like this. It's ching, 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 like that, except for it's a right angle. So let me try again here with my, there we go, right angle. So here, this long side is called the hypotenuse. Hypotenuse. Very hard to say. And that, in this equation, represents C. Then this is a leg, and this is a leg. Okay, and this is A, and this is B. And here's the thing, is it doesn't matter which one's A or B, as long as the shorter ones here are the legs, the ones by the right triangle. Okay, hypotenuse, the way to remember this, is always across from the right angle. Okay, so there we go. We got A, B, and C. Now the question is, how do we figure out what is happening? Well, look at the drawing here. So if you need to write that, go ahead. Look at their drawing, right? They have the triangle like that. Okay, and they say one side is 3, one side is 4, and one side is 5. Okay, now remember what I said. This is A, this is B, and this is C. So when we have this theory, right, we take a squared, right? So we have a squared plus b squared equals c squared. Let's see if that's true. Okay, so we have a, which is 3 squared plus 4 squared equals 5 squared. Well, is that true? Let's find out. What is 3 squared? That's 9 plus 4 squared, which is 16. Does that equal 5 squared, which is 25? Is 9 plus 16 25? The answer is yes. So that means that we know this actually has a right angle. 3, 4, 5. Okay, so let's look at example 1 here, okay? So they give us example 1 on that page, and it says the legs are 8 and 15. So what that means is when we have our triangle here, this one is 8, this one is 15, and that one is C, and we don't know what C is. So we do have our formula though, right? So this is A. Doesn't matter which one, 15 or 8 can be A and B, it doesn't matter. So we have 8 squared plus 15 squared equals C squared. C is our variable. Very important. Okay, so let's do, what is 8 squared? Well, that's 64. Plus what is 15 squared? That's 225, right? You have your calculators. Equals C squared. Okay, now I add them together. What is 64 plus 225? Well, it's 289 equals C squared. Now, this is where we use what we just learned in our radicals, right? We don't want to know what C squared is. We want to know what C is, what the actual length on the drawing is. So we take the square root, right, to get it to just be C. And the square root of C squared is C. And what's the square root of 289? Punch that in your calculator and you get 17. Sorry, I don't know why I wrote 13. You get 17. Okay, so now we know that C over here is 17 by using our Pythagorean theorem. Okay, not too bad. Let's do another one for example. So the next one on example 2 on the next page. So this is example 2. The way that works is it says 6 and 7. The legs are 6 and 7. Okay, so when I come over here, if it helps you to draw it, I would draw it. You got 7 and 6, and you got C. You want to know what C is? So we have 6 squared plus 7 squared equals C squared, right? That's our formula. I square 6, which is 36. I square 7, which is 49, equals C squared. What's 36 plus 49? Well, that's 85. So you get 85 equals C squared. Now, to find the answer, I take the square root of C squared and the square root of 85. Square root of C squared is C. Now I use my calculator, and I punch in the square root of 85 because it's not a perfect square, and I get 9.2. So because I get 9.2, that means C up here is 9.2. So it can come out to be a fraction, y, or a decimal. I prefer a decimal because it's a length, right? So it's actually there. The square root of 85 is a length, in this case, 9.2. Okay, so let's do a few more examples like that, and then we'll keep chugging. This is the easier way. What if the legs, okay, the legs are 10 and 24, right? All I do here is I go 10 squared plus 24 squared equals c squared. This is 100 plus, I have to use my calculator for this one, 576 equals c squared. So I know that this is now 676 equals c squared. I take the square root, and I get c equals, I punch in my calculator, the square root of 676, and I get exactly 26. And there's my answer. So if you need to slow down and plug that in your calculator and do it, that's how you solve those. Now the great part is, we can also solve this when we're given the hypotenuse, when we're given c squared. So let's say they give us a triangle, right, that looks like this, and they say this is 13, and this is 5. And they say, what is b? Well, all we do is we come back to our formula, a squared plus b squared equals c squared, and we just plug these in. So I'm going to call this guy a, so 5 squared plus, I don't know what b is, so b squared, that's not a 6, equals c squared. I know what c is, he's 13. So now I just square it. What is 5 squared? 25. What's b squared? Well, that's what we're trying to find out. And what's 13 squared is 169. You punch that in your calculator. Now we're trying to solve for b squared. So what am I going to do? I got to just do it like an equation. Subtract 25 from both sides. Like that. And I get b squared equals 144. Now, to solve for b, because I don't want to know what b squared is, I want to know what b is, I take the square root and I get b equals 12. So I know that b down here is 12. Okay, it's just the inverse order. So it doesn't matter if they say the hypotenuse, that means the one that's c squared. Okay, so let's do another one like that, just to make sure we got it. So we have hypotenuse is 16 and leg is 7. Okay, if it helps you to draw it, I got 16 over here, 7 here, and I don't know, let's say this time I don't know what a is. So I'm going to have a squared plus 7 squared equals 16 squared, right? I just plug those in right into my formula. I get a squared plus 49 is 256. I do believe, right? Yep, 256. Now I'm trying to find a squared here, so I just subtract 49 from both sides. Subtract 49, get a squared equals 207, and that's not a perfect square, but I still take the square root, and I'm left with a equals, when I punch it in my calculator, I get 14.4. Okay, so that's just the inverse operations. Okay, not very hard to do, very straightforward, okay? So now, where the lesson gets a little more interesting, just for fun, is this is also true if a squared plus b squared does not equal, okay, I'm going to circle this because it's very important. If it does not equal c squared, then it is not a right triangle. Okay, if they don't equal, then it's not a right triangle. Need an L there, huh? Okay, we'll show a few of these and then we'll jump into our homework. So, let's look at this one. They say that the sides are 12 and 35, and the hypotenuse is 37, and then it's a right triangle. All we do to test this is plug it in a, b, and c. So we do 12 squared plus 35 squared equals 37 squared. Is that true? So this is 144, and then 35 squared is a big hulking number. It's 1225, and does that equal 37 squared, which is also a very big number, 1389. When I add these two together, guess what I get? 1389. And so then, is that a right triangle? Yes. Cha-ching. Yup. It's a right triangle. Yay. Now, let's do one. Let's do it again and see if we can still find our right triangles now. Let's see if it's 8, 12, and then the h, the hypotenuse, is 14. Okay, so I have 8 squared plus 12 squared equals 14 squared. So 8 squared is 64, 12 squared is 144, and I add those guys together. I get 64 plus 144 is 208, and I say is 208 equal to what is 14 squared? I punch that in my calculator. 14 squared is 196. Uh-oh. No, it's not equal. So that means nope. Not a right angle. It's an angle, but it's not a right one. So that's pretty much all of the homework. It's not really going to get any harder than any of those things. So if you followed along and you were able to do those, good luck. You're going to do awesome on the homework. So speaking of homework, here it is. It is on page, can you guys believe this, 467. This is 11.4. And we're going to be doing 1 through 27 odd. Okay, 1 through 27 odd. There's your homework due on Wednesday. Okay, good luck. Pretty straightforward. Please email me if you have any questions. Okay, Mr. H, over and out.